Hello everyone. Let us now discuss how can we solve this problem. Count the number of complete components. We are given with integer n. There is an undirected graph of n vertices numbered from 0 to n minus 1. We are given with two integer array edges where edges of I is equal to ai bi. That means ai is connected undirectedly with bi. That means this is in bidirectional way. Now, return the number of complete connected components of the graph. Now, what is a complete connected component? So, a component is something like here. If you see this, this is called one component, or this is called one component. If you see, it's like an island where you see in a water, and this would be like something like island if you have already solved number of islands or number of components similar to it. A connected component is a subgraph. Now, what is a connected component? It is a subgraph of a graph in which there exists a path between any two vertices and no vertex of the subgraph shares an edge with a vertex outside of the subgraph. So they are saying that here C0, this component is having 0, 1 and 2 as the vertices. Now 0 should be having an edge with all the other vertices in the subgraph or this component. Let us see, is it having all the edges or edges with all the other components, all the other vertices in the component. Now 0 is having with 1 and also with 2. So it is having edge with all the other vertices in the same component. Now let us go to 1. 1 is having edge with all the other vertices in the same component. Now 2. 2 is having 0 and with 1. So it is having edges with all the other vertices in the same component. But if you see this component is having only one vertex. It is not having any other vertex. Instead, only it is having only one vertex. So no need to worry about whether it is a complete connected or not. It is initially and it is finally a completely connected graph because it is only having one vertex. Now let us see this 3 and 4. 3 is the vertex. Now it is having the edge with all the other vertices in that component. So let us go through 4. 4 is having edge with all the other vertices in the same component, which is 3. So the number of complete connected components are 1 and then 2 and then 3. So totally we have 3 as the output. But this would be the second example. Here this component, this 5 and this 4 are not connected. Instead they are not connected, so all it is not connected with all the other vertices in that component. So there is only one connected component, which is this one, completely connected component. Now let us see what will be the intuition. Now let me take something like this component is having vertex, only one vertex. Now let me take this component which is having vertices, 3 vertices. Let me write it over here, 3 vertices. Now we have 2 vertices in the third component. We have 2 vertices in the third component. Now if you see, 0 is connected with 2 vertices. 0 is connected with 2 vertices. Let me write it here. 0 is connected with 2 vertices. Now 1, let me go to 1. 1 is connected with 2 vertices. 1 is connected with 2 vertices. Now let me write it over here. 1 is connected with 2 vertices. 2 is connected with 2 vertices. As it is an undirected graph, or it is a bidirectional graph, any two vertices which are connected are, 1 is connected with 2 and 2 is also connected with 1. So we can go from 1 to 2 and also 2 to 1. So Now 2 is having 2 vertices connected to it. Now, wait a second. Here, if you see, I got all the vertices or the count which is connected with every vertex is 2. Let me go through the second component, or the here it is the third component, right? Now, I have 3. 3 is having connected with only one vertex, which is 4. So the number of vertices connected by 3 is only 1. Now 4 is connected with 3, which is only 1. So 4 is having only one vertex connected to it. Now 5. 5 is having no vertex connected to it. So 0 is the count. But if you see, 3 is the number of vertices we are having, and 2 is the count of all the other vertex that need to be connected, which is indeed a simple logic that if you need a complete graph, every vertex should be connected with all the other vertex. If I am removing one vertex, what are the number of vertices that this vertex should be connected with? If I am having k vertices, now I need this vertex. This vertex should be connected with all the other vertex. So I am initially having 3 vertices, k vertices. So I am removing this, or I am considering one vertex, so it should be connected with all the other vertex. So what is the number of all the other vertex? It is k minus 1, which is 3 minus 1 in this example, which will be 2. For 2, it is 1. Here it is the number of vertices. K is 1 and here it is 0. So, my logic, the first intuition, let me write it here. My first intuition is a vertex. A vertex should be connected with k minus 1 vertices. Okay, it should be connected with k minus 1 vertices, where k is the number of vertices in a component. So a vertex should be connected with k minus 1 vertices, where k is the number of vertices in a component. But my problem is, what are my problems, right? What I need to get? I need to get what are the components. What are the components? What are the components? And the second thing is every node in that component is satisfying the condition. So if I figure out these two things, what are the components, or nodes, what are the nodes in one component, and is every node in that component is satisfying the condition. Now let me take the same example and let me write it over here. So here I will do one thing here. Let me name this component. Let me name this component or give an ID to it. Here initially I am not doing anything. So here I got a 0. So the first thing, if you do any traversal from 0 to n minus 1 to n or lesser than n, which would be till n minus 1, I will go through 0 first. So the component which is having a 0 would be my first component or 0th component. Now I have gone through 0, 1, 2, and I will go through 3 and 4. So this would be my first component and this would be my second component ID 2. Now I will go through 0 to lesser than n. So I am starting with 0 and naming my component. Till now my component is 0, right? Now I gone through 0. Let me do this. I gone through 0. So the first thing which I need to do is it is 0, my component is 0, and it will be having some nodes. So it will be having some nodes. This, see here, component is 0, component is 0, and what are the nodes in it? What are the nodes in it? It is firstly 0. Then I will do any searching algorithm. Either you would like to do in DFS, you can do it, or you can do it in BFS traversal. But instead of doing this search, I directly get the nodes in this. Now I go through here 1, so 1 here, and then I go to 2, then I get a 2 here. So that's it. Here, if I go, I will get it is already visited. So I won't visit it again. Now, here I started with 0. Now, let me go from here. I am doing this loop condition. So I am going from 0 to n minus 1. Now, I go to 1. 1. Is it visited? It is already visited. So why shouldn't I use this visited array? So 0, 1, 2, 3, 4, and then 5. I have all everything as false. Here it is false, here it is false, false, false initially, but when I go through 0, I make it as true. I make it as true. I went through 1, so it is already visited, so I make it as 1, sorry, true, and then here it is true. So 1, when I go to 1 in the loop, when I meets 1 in the loop, 1 is already visited, so I can't do a DFS there. Let me go through 2. 2 here is already visited, so I can't go through 2. Now let me go through 3. Here 3 is unvisited. Let me do a DFS there. But before that, I need to increment my component, because here it is one component, and whenever I go through 0, it will traverse all the components and all the edges, sorry, nodes or vertices in that component, and whenever I doesn't get any component, sorry, any another edge or the vertex from that 0, that means this component is completed. That means I need to increment my component ID. Now here the component ID is 1, so let me write it over here. Component ID is 1, so the first edge, sorry, the node is 3. Now 3 is made as visited. So let me do any search, or either a DFS or BFS. I am doing DFS here. So I go through 4. So 4 should be visited. So 4 is marked as visited. Now I doesn't have any other nodes which are unvisited. So that's it. Now I have a 4 here. After that, I go through I. But before that, I will increment my component, because I am out of the component 1. Now, I go through 4. It is already visited and it is marked as true, so it is already visited. So I go through 5. 5. Is it visited? No, it is not visited. So my component is 2 and the node is 5. Right? Here it is 5. Now 5 is visited and it is true, and it is marked as true. Now is it having any another neighbor so that we can visit it? No, we doesn't have any neighbor. So that's it, we go out of bounds for this loop. So what is my intuition is, first thing, I will make sure that by getting through these edges, I will make sure that I get the in degree for every node. 0 for 0, I am having in degree of 2. For 1, I have in degree of 2. For 2, I have an in degree of 2. Sorry, in degree or out degree. So both are added, then my degree will be 2 for 0, 1 and 2. Then for 3 I have degree of 1. For 4 I have a degree of 1, and then for 5 I have a degree of 0. Now I go through every component and go through the node for every component, and I will see whether this node is having, my intuition is this node is having degree of k minus 1. What is k here? K is size of nodes or the number of nodes in the particular component. So it should be 3 minus 1, which is 2. So it is 2. So whenever I get any node which is not having k minus 1 as the degree, get out from that component and go through the next component. Now, if every node, let me change the color, if every node in that component is having degree k minus 1, k minus 1, where k is the size of this node, the number of nodes. If it is every node is k minus 1, then only increment the answer. So this component is a valid component or completely connected component. So by using the same thing, let me go through this. Another thing, 0, 1, let me write the visited, 0, 1, 2, 3, 4 and 5. Everything is initialized as false, 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 and then false, and then. Now I have started with 0, 0, and then I go to 5, but I will start with 0 and my component is 0 initially. Now 0 is the first node. Let me write this component and nodes as int comma vector int in C++, right, in an unordered map. So component is 0 and the nodes are initially 0. So if I do a depth first search, then I get a 1 here, then I get a 1 here. So 0 is visited, so let me do this as true. 1 is also visited, let me do this as true. Now I get 2, 2. So 2 is pushed back into this component. Now 2 is also made as true. There are no another nodes 2 is component and unvisited with. So it is connected with 0, but 0 is already visited, so don't go through that 0. So these are the components. So I will increment the component to 1. Now I will go through 1. 1 is visited, so skip. 2 is visited, so skip. 3. 3 is not visited. Now my component is 1 and the first node is 3. So 3 is visited, so mark it as true. Now I have 4 which is connected with 3. So 3 will be inserted or pushed back into component 1. Now 4 and make it as true. Now after that I will go through this 5 return back from 4, and then I will go through this 5. Now for 5 I will push back this into component 1. Now 5 is also marked as true. So after this 3 I will increment my component to 2. There is no need, but I will increment by the code. So 4, is it visited? Yes, it is visited. 5, is it visited? Yes, it is visited. Now let me write the in degree, or sorry, degree for every node. For 0, 1 and 2 it is 2. For 0, 1 and 2 it is 2. Now for 3, 4 and 5, let me go through 3. For 3 it is 2, 4 and 5 it is 1. 3 it is 2. For 4 and 5, 4 and 5 it is 1, right? Now let me see whether I am having this, right? So 0 should be having degree of 2. So 0 is having degree of 2. So go to the next node. 1. 1 is having degree of 2. So go to the next node. 2. 2 is also having degree of 2. So I will increment my answer here. So Till now, my answer would be 0, but I got a component which is completely connected, so I will increment it to 1. Now I go through component number 1, which is having first node 3. 3 should be also having 2, as it is the number of nodes is 3. K value is 3. I need k minus 1, which is 2. 3 is node 3 is having 2 as a degree. So go to the next node 4. 4 should be having 2, but it is only having 1. So I break the loop here itself and go through the next component, but there is no next component. I will return answer here itself. So that's the whole algorithm for this question. And if you want the code, it is given in the description. I have given the link of the code in the description. So if you like this video, do share it to your friends and do subscribe to my channel. Thank you.